Hello students, so today we will discussing about the how to make a band pass. So basically band pass is divided into two parts. First is the high pass and second is the low pass. So first we see the circuit diagram how to make a high pass. This is the simply using the IC741 plus VCC is the 7 minus VE is the connect with a 4. Third terminal is the non-inverting and the second terminal is inverting with connect with RF and R1. And here you see the capacitor. This is our V input and this is R. So all about the circuit. Now the how to find the frequency. So you first consider the gain. So now here I consider the gain is 3. So 1 plus RF upon R1, 1, 3 minus 1, so 2. So RF equal to 2R1. It means it indicate that if I select the R1 is the twice of the RF equal to, right? So if I select the 10 kilo ohm R1, so it's the RF is the my approximately the 20 kilo ohm. So this is the basic calculation for RF and R1. Now I consider the frequency for the high pass and low pass. So here I consider frequency is the 800 Hz. So for the 800 Hz, I firstly select my capacitor is the 0.01 microfarad. Then the subject of the formula R. So R equal to 1 upon 2 pi F into C. 2 is constant, pi is value we know that 3.14, F is the we already consider is 800 and the C is the 0.01 10 to the power minus 6. So after the calculation we get the it's approx the 10 kilo ohm. Similarly process we do for the 1600 hertz. So this similarly process we do it, so we get the approximately 22 kilo ohm resistor. So now here we see the circuit diagram for the high pass and low pass filter. So this is my first circuit is the basically my high pass and this one is the low pass, yes. And now I connect with this is my 6 terminal and it's connect with my the third terminal is the non-inverting. So third terminal connect with my resistor. This my capacitor is now ground and this is the also my resistor which have the in the second terminal is ground. This is my RF. This is 22 kilo ohm. And this similarly all the process are here done, but here capacitor is input and now here resistor is connected with a ground. So this is the all about the circuit. So now let's see what happened after the connecting the all the both circuit. So let's see output. This is my circuit. This is my 15 volt power supply, right? You see this is positive, common and negative. It's all are the connected with each other. And this is my input is the known as the frequency generator. It's frequency. And this is my oscilloscope that I see the output using the simple. This is the wire I connect with output and ground. So you see this is output and ground. But here the one of the most important thing in this practical, you use the particular the instrument wire, so you get your output is very precisely. So now here I consider the 100 Hz. You see it, this is the very simplest frequency generator. You see the 100 Hz and now we see in the now you get your output here. So you see it, it's a waveform. Now if I press the auto set, so let's see what happen it gives. So this I see the 200 millivolt. Now I slightly increase. If I increase the 200 hertz, so let's see what happen. So this is my 200. So now if I decrease the amplitude, then you see it first my at the 100 I have the 200 milliwatt. Now it's completely rise is 380 milliwatt. Now if I the vary the at 300 hertz, so you see it, I get the output is the 500 millivolt. If I increase the similarly 400, so I get the 600 millivolt output. So you consider is the in your observation table with easily. If you do draw your observation table, so first you draw here the frequency. Here you draw first frequency, then draw the output, then you get the log of F, then again V output upon V input. V input here fix how to get V input. This is the equation. So this is nothing but this is your V input is the both the two terminal and the V output. This is the both the two terminal. You connect to each other and you get the output. Or if you know get it, you already know about that. Here we set the 1 volt. So you get approximately 1 volt in the output. So this is the basic thing. Now you get it after the you take the dB for the 20 log into multiply with again So this is the basic observation table. You vary with 100 to 2500 because the my frequency is the low is the 800 and high is the 1800 hertz. So let's see what happened. So this is the my 500. So you see it here easily. It's give to the 618. Then if 600, then 736. Now the 700. So it's give the 760. Now my the low frequency is start is the 800. So you see it. It's a variation is the 784 something. If I hear the 900, then it's give to the value as the 784. Right. So you just wait it may be a vary. So it 820. If I hear 1 kilohertz, so you see it constant. It means my the band pass filter it will work now. If I consider the 1.1 kilo ohm, you see it now here the 1.1, it means the 1100 hertz. So you get it the 820, it constant. If I 1200 kilohertz, so it is same for the 1300. So it is also near about the same. Then 1400 it will be start to decrease. It means this is my region for the low pass and high pass is completed. Now my frequency is the continuously decrease. So how do you check your practical work or not? It will be decrease after the certain region. So you see it will be decreased now. You see it will be 820 to decrease the 670. If I set as a 2 kilohertz, so you see the continuously the decrease is the 700 milliwatt. If I set the here the 2500, so you see it clearly it is the 640. It will be mostly decreased. So this is the basic practical for the band pass filter. Thank you.